Topic 11, Lesson 1, Factors. Well, so far you've learned how to make equal groups. In this lesson, you'll use what you know about equal groups to find the factors of a number. Our standard is to find all factor pairs for a whole number by the range of 1 to 100, and recognize that a whole number is a multiple of each of its factors, and determine whether a given whole number in the range of 1 to 100 is a multiple of a given one-digit number, and determine whether a given whole number in the range of 1 to 100 is prime or composite. Our mathematical practice is we're going to make sense of problems and persevere in solving them, reason abstractly and quantitatively. We're going to construct viable arguments and critique the reasoning of others. We're going to look for and make use of structure, and we're going to look for and express regularity in repeated reasoning. Our focus is how can you use multiplication to find all the factors of a number. Now, factors are the numbers you multiply to get the product, and the product is the answer to a multiplication problem. So our factors in 3 times 6 equals 18, the factors are 3 and 6. Those are our two factors for this particular problem. Jared has 12 flowers, and he wants to plant them in equal rows in his garden. What are the different ways he can arrange the flowers in equal rows? So again, we have 12 flowers, and we want to put them in equal rows, and there's multiple ways of doing it. In fact, it even says there are different ways he can arrange the flowers. What could he do? Let's take a look. Well, we can look at it this way. We can see that he could actually have one row of 12 flowers. So that would be really 1 times 12. He could have 2 rows of 6 flowers. So that would be 2 times 6. He could have 3 rows of 4 flowers, 3 times 4. Or 4 rows of 3 flowers, 4 times 3. 6 rows of 2 flowers, 6 times 2. And 12 rows of 1 flower, 12 times 1. So, and you could even draw this. In this case, for example, he could have 1 row and 12 flowers in it. Or in this case, he could have 2 rows and 6 in each one. Or 3 rows, 1, 2, 3, and there's 4 in each one. And you can do this for all of them. The key is that there are equal range of flowers in equal